Okay, picking up our Unit 2 review for Math 1, Unit 2 test coming up pretty soon here. We did the first 5, now number 6, Shirley starts with $85 in the bank and saves $15 every 2 months. Write an equation for the balance of Shirley's bank account. Be sure to define your variables. So this is a tricky one if you haven't dealt with a lot of word problems. Right, we know our equation for a linear function is this, y equals mx plus b, and it asks me to define the variables. So that means, okay, well, which one of these numbers up here is x and which one is y? Right, so if I think about what this is, y is the total amount that she has. And x is how many months she saved, right? If we were going to graph this, it would be something like, right, the amount of money and the number of months, right? So after how many months, right, how many dollars did she have, something like that, right? So we know what our variables represent. So when I fill in my equation, right, we can, right, see x is going to be the number of months, y is going to be the total, right? So that's important. And then the two pieces of information it gives me, right, the $85 that she starts with and the $15 every 2 months, those are going to represent the, right, the start value is the y-intercept, and the rate of change, right, 15 every 2 months is the slope, right? So y is the total amount, x is how many months. The slope is $15 every 2 months, and the y-intercept is $85. So if I want to take all that information and write an equation, y equals 15 over 2 x plus 85. Right? The start value, the rate, those are always going to go in the same two places. Okay, number 7, let me put that there for one more second. Number 7, what is the slope for each of the lines with the points shown in the table? Show your work, right? So this is really important that we're able to show our work. So remember our slope, I'm going to write it, don't want it to get in the way, so I'll write it up here, right? Our slope is equal to the change in y divided by the change in x. So for each of these problems, we need to first find the change in y. How is the y changing? And then we need to find the change in the x. How is the x changing? And then our slope is the change in the y divided by the change in the x. All right, so for this first one, problem A, the change in the y, if we just look at these first 2 points from 19 to 14, that's going down 5. And if I look at the x coordinates for those first 2 points from -2 to 1, right? Remember, we're getting closer to 0. That, from -2 to -1 is actually going up 1. So my slope would be change in y is -5, and the change in x is 1. That's my answer. And I could, remember, I can pick any points I want. If I would have picked, like on part B, it's the same exact, right, change in y divided by the change in x will define our slope. But I don't have to pick points that are right next to each other. Let's go, I don't know, let's just pick these two, right? I can pick any two I want. So from 31 to 49, that's positive, goes up 18. And from 3 to 5, that also goes up, so the change in x is positive 2, 3 to 5. So my slope is change in y 18 divided by change in x 2. So 18 divided by 2 is 9. So my slope is 9, right? And if I actually look at every single one of these, 2, 3, 4, 5, 6, these are going up by 1s, and these are going up by 9s right here. So 9 over 1. If I would have picked the ones right next to each other, I would have had the same outcome. Okay, number 8, draw figure 0, then write an equation for the given tile pattern. How many tiles will be in figure 58? So what we did in class was we kind of started by, look, there's 4 and 2, and there's 4 and 2, and there's the 4 and the 2, and then it added 2 and 1, 2 and 1, and then I can see, oh, it continues to add 2 and 1. So as it's changing, right, remember this is like my x in green like the last one. That's my x, and my y is the number of figures, or number of tiles rather. So 1, 2, 3, 4, 5, 6 in this one, and it added 3 every time. So if I count them up, I got 1, 2, 3, 4, 5, 6, 7, 8, 9. And I can see it added the 3 green ones here, but if I double check counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right, it's adding 3 every time. Right, the change in y is plus 3, and the change in x is 1. So if I go backwards, right, it's going to lose 3. So which 3 does it lose, though? That's the question, right? So it's adding 2 on the bottom, so it'd probably lose these 2, and it's adding 1 on the end, so these 2. So our initial 3 would be these 3 right here. So the initial one would look like that. So figure 0 would have 3. Right, so my change is 3, right? Remember for these we did kind of our starting, right? This is my y-intercept. So it starts with 3 and then it grows actually by 3. So my equation, y equals 3x plus 3, right? Keeping in mind this is the start value, we called it, start value. Right, and this was the growth. Right, so this one's tricky, maybe if you weren't quite sure what happened there, because they both turned out to be 3, right? So make sure we know which 3 goes where, right? This 3 right here is this one, and this 3 right here was this one. Oops, and it actually asked me to do something extra for this one. So it asked me to figure out what happens when we're at figure 58. So what happens when x equals 58? So plug it in. When x is 58, we plug it in. 3 times 58 is 150 and 24, so 174 plus 3. So figure 58 would have 177 tiles. That's a lot easier than drawing this expansion visually 55 more times. Okay, number 9, what is the slope of the line that passes through the points -5, 7 and 10, 1? So I think our best bet for doing these is to make a little table. It's going to go like this, little mini table. So the first point, the x was -5 and the y was 7. And for the second point, the x was 10 and the y was 1. So we're going to do exactly like we did before. We're going to find the change in y. From 7 to 1, it goes down 6. And we're going to find the change in x. From -5 to 10, it goes up, so positive 15. So my slope is negative 6 divided by 15. Right? And I can actually reduce that. 3 goes into both those numbers, so negative 2 over 5. Okay, evaluate the expressions below for the given values. So this is my last problem on here, and this was a tricky one for us on the last. We were good on this on previous efforts on the tests and in class if we didn't have too many negatives going on. So let's kind of really focus on that. The first thing I want to do every time I'm asked to evaluate an expression is go just to the variable and put parentheses around just the variable. That's going to allow me to only to see where the variable is. So when I plug in, I'm only applying the rules to the right part. So, all right, so I'm going to have negative 3. Right, there's my parentheses. That's the x is inside there. X squared plus 4x plus 5. Right, that's my equation. I rewrote it, or my expression rather. There's no equal sign, right? So it's not an equation. And I'm going to plug in x equals negative 2. So all the x's were, I'm going to substitute in negative 2. Right, by putting parentheses there, it is going to help me see what happens with the exponents especially. And even if I don't use the parentheses and I type it into the calculator, it's probably going to do it incorrectly. Because you're not, the calculator doesn't know what you know about that you're evaluating a certain number. It's just going to do the order of operations however you plug it in. So I end up here with negative 3, and negative 2 squared is positive 4, plus 4 times negative 2 is negative 8, plus 5. Right, so negative 3 times 4 is negative 12. Plus a negative 8 is minus 8 plus 5. So negative 12 minus 8 is negative 20. Making sure double checking my work here. Yep. So negative 12 minus 8 is negative 20 plus 5 is negative 15. All right, part B. Now it asks me to evaluate when the x equals 1. So I'm going to go ahead and write the equation again the exact same way it looks. All right, except where I had an x, I put empty parentheses, and now I'm going to go through and I'm going to put in a 1. All right, it's not as big a deal if the x is positive because you're probably not going to, it's not going to end up messing up your sign probably, but we want to be careful and consistent with what we're doing. So 6 minus, right? Remember parentheses, I do everything in parentheses first, PEMDAS, right? So 5 times 1 is 5 minus 9. So I'm only doing one thing every line. That's really key here, right? So now I'm just going to simplify. 5 minus 9 is negative 4. Negative 4 squared, right? Exponents come next, so I have to do this whole part here first. Negative 4 times negative 4 is positive 16. And 6 minus 16 is negative 10. All right, we're almost there. So now it's asking me to substitute for when k equals negative 8. So just a different variable, no big deal. Okay, so we have negative 4 over k. So I'm going to put, right, parentheses where the k was, plus 7. And the k was negative 8. The top doesn't change. Negative 8 plus 7 is negative 1. Now I just have a fraction, but the top and the bottom are negative, so it's going to cancel out. A negative over negative is a positive. 4 over 1 is 4. And we're down to the last couple here. This one now has 2 variables in it, so it's going to ask me to evaluate when the m is negative 2. And let's go when the n is 3. So again, where's my n's? I have an n there. an N there, and I have an M there, orange, M there, and there. So just the M and the N, just the letter, not the exponent or coefficient or anything else. So I'm going to go ahead and write this, right? So I have 2n over, M actually, over, you know what, I'm going to do this a little bit different. So 2m, and I know m is -2, over, and the bottom I have an n, which I know is 3, minus 1, and that whole fraction minus m to the third power, and I know m is -2, minus n, which I know is 3. Right, so this is definitely one where the parentheses are probably going to help me, because you can see kind of in this middle part right here, those negatives might get messed up, or even over here, the negatives might get messed up if I don't have these parentheses in place. Especially if I put it in the calculator, if I just put 2, -2, then it's going to do 2 minus 2, and I definitely don't want that. So let's go through each piece. 2 times -2 is -4 on top. 3 minus 1 is 2 on the bottom. Minus, now we're just going to deal with this part right here, right? -2 to the third. So -2 times -2 is +4. Times another -2 gives me -8 minus 3. So I kind of ran out of room there, but -4 over 2 is -2. Minus a -8 is +8 minus 3. -2 plus 8 is 6. 6 minus 3 is 3. All right, so that was a lot of steps, a lot of substitution. Cubing a number, right? Third power exponent with a negative is going to keep it negative or go back to being negative after it turns positive. So we got a lot to keep track of on that one. And then the last one, in part C, if f of k equaled -4 over k plus 7, what value of k would be excluded from the domain, right? So we haven't talked a lot about domain in the recent weeks. We did before the last chapter, right? But remember, domain means what are the possible x values, right? Well, this is asking me what would be excluded. So that's saying what value of, well, I guess we always said x values because we dealt with x variable, but here it's k. So what are the possible k values? Since that's the variable it chose for this one, right? It's f of k. So that's just like an x. You could call it whatever you want. Nothing special about x. So possible k values, well, k could be anything you want in the whole world. You can plug in any k you want, as long as in a fraction it doesn't make the bottom 0. Right? There's other restrictions too, but for this problem, we can't have the bottom be 0. Right? So remember, a fraction, the 0 on the bottom is not defined, at least not yet. Right? So -4 over 1 is not defined, so, or 4 over 0. So that means k plus 0 can, or k plus 7 cannot equal 0. Right? So that means k cannot equal -7. So for that function, k could be anything except -7, because a -7 would make it an undefined function. Okay, so that concludes all the problems in about 35 minutes that you need to ace the next test and be prepared for all the things that are coming your way in Chapter 2. So go through the video and pause at the parts that you need. You can view the solutions, and I'll leave this up there for your viewing.